Hello, algebra students. This is a continuation on the complex numbers and the imaginary unit I. Make sure you've seen that part of the lecture before you move on to this because it just isn't going to make any sense. So this is the part where we're going to start using I. We are trying to solve equations like x squared is equal to negative 32. Now, our process for this is to solve for the thing that's being squared, which in this case is x, and then take the square root of both sides. So here you would look to take the square root of both sides, and the square root sign and the squared sign cancel each other out, so you would just have x equals. And remember, historically, if you ever had the square root of a negative number, you would just say no solution. However, because we now know that the square root of negative 1 is equal to the letter I, or the number I, we can now do this problem. We have to imagine simplifying the square root of 32. The process for that would be to find any perfect square factors. Remember, the perfect squares are 1, 4, 9, 16, and continuing on like that. The biggest perfect square factor is 16, so you would break up the square root of 32 as the square root of 16 square root of 2. However, this is also a negative 32, not just 32, so you also have a square root of negative 1. Remember, when you take the square root of both sides, you also have that plus or minus. So we can do some simplifications here. We have x is equal to plus or minus. We know the square root of 16 is 4. The square root of 2 cannot be simplified. And we know that the square root of negative 1 is actually I. So it would be 4 times the square root of 2 times I. Now, I told you guys this in the last lecture, I know, but we don't like to write the I after the root sign. The reason for that is because it's like, well, is the I underneath the root or not? So we like to put the I right there. So it would be x is equal to plus or minus 4I root 2. And that would be your answer. Remember, the reason that you can simplify negative 32 into 16, 2, and negative 1 is because if you multiplied all of these things, you would get negative 32. Let's look at a couple more examples. This one here, the thing that is being squared is this n, right? N is being squared. We need to solve for n squared. And so you're going to undo the minus 7 and then multiply by 3, just like you would have in previous sections. And like if this, in algebra 1, you'd first add 7 and add 7. So you'd get 3n squared is equal to negative 24. The thing that is being squared isn't by itself yet. It has a multiply by 3, so you're going to divide both sides by 3, and you would have n squared is equal to negative 8. Now is when you take the square root of both sides to get rid of the squared sign, so you would have n is equal to, remember, taking the square root of both sides creates a plus or minus. So you'd have plus or minus, and then you look to simplify the square root of 8. And you look at your perfect square factors, and 4 is a factor of 8, so it would be root 4 times root 2. We also are taking the square root of a negative, so we'd also peel off a square root of negative 1. Remember, all three of these numbers do in fact multiply to negative 8, so that was a good simplification. We know the square root of 4 is 2. Root 2 cannot be simplified, and the square root of negative 1 is I. And then remember, we don't like I at the end like this. We don't like it after a root. We like it right before the root. 2I root 2. And that would be your answer. Let's do just two more, and then that's going to be it for this lecture. The thing that is being squared in this problem is x minus 3, so that's the thing I want to solve for. I'm going to start by subtracting that 11, so I'd have 2 times x minus 3, and that squared is equal to negative 48. Remember, I'm trying to solve for the thing that's being squared, so I have to undo this 2 out front, and I'm going to undo the 2 by dividing by 2, so I'd have x minus 3 squared is equal to negative 24. Now is when I would take the square root of both sides, Square root and square cancel each other out, so we have x minus 3 is equal to plus or minus the square root of negative 24. Remember, the way to simplify the square root of any square root is to see if it has any perfect square factors. Once again, we have 1, 4, 9, 16, 25, continuing on like that. 24 does have 4 as a factor, so this would be x minus 3 is equal to plus or minus the square root of 4. 4 times 6 would be the 24, and then it's negative, so we're also going to have a square root of negative 1. X minus 3 is equal to plus or minus. I'm going to simplify these. Of course, I can simplify the square root of 4, which is 2, and the square root of 6 cannot be simplified. None of these numbers are factors other than 1, which is the trivial example. And we know the square root of negative 1 is I. Remember, we like the I to be in front of the root. So this would actually be x minus 3 is equal to plus or minus 2I root 6. And then x isn't by itself yet, so we need to add 3 to get it by itself. So we would have x is equal to, if I add 3, I'm actually going to put the positive 3 in front of the plus or minus. We did the same thing with roots in a previous lecture. So we'd have 3 plus 2I root 6 and 3 minus 2I root 6, and that would be our answer. Last one, I would encourage you guys to try it, and then we'll go through it together. It is easier than this example here. Remember, we are trying to get the thing that's in parentheses by itself. So it has a negative 5 in front of it, so we're going to divide by negative 5. So we would have n minus 3 squared is equal to negative 2. Now I have the thing that's being squared by itself, so I'm going to take the square root of both sides. The square root and the square cancel each other out, so we would have n minus 3 is equal to plus or minus. Now we have the square root of negative 2. Now the square root of negative 2 doesn't have any perfect square factors, but it still does have that negative 1 that we need to peel out because we have a negative underneath our root. So it would look like n minus 3 is equal to plus or minus the square root of 2 and the square root of 1. Remember, these things multiply to negative 2, so that is a legal move. N minus 3 is equal to plus or minus. Remember, the square root of negative 1 is I, and we like to write that in front of the root. And we're almost done. N isn't quite yet by itself, so we're going to add 3 to both sides. N is equal to 3 plus or minus I root 2. So that is kind of solving equations that you're going to end up having a square root of a negative number. Right? That's what all these examples have in common. Please reach out to me if you have any questions on this task.